Assalamualaikum in height. We would like to present our final year project, measurement of carbon dioxide emission at levels at a city closer in Bandar Maharanima is the title of our project. This is our group members and our supervisor TS Muhammad Erwan bin Sani. For background of study, carbon dioxide emissions are increasing daily in an era of globalization. Carbon dioxide is one of the most harmful greenhouse gases. According to the IA, the world's transportation sector was the second largest emitter of carbon dioxide in 2008. Accounting for 22% of global carbon emission, one of the options is to control carbon emission, which is critical for overall world sustainability and livability. We discovered three problem statements for our project. Okay, the first one is the emissions produced by motorized vehicles are a significant impediment to the government's goal of achieving carbon neutrality at the city level. For the second one is the National Low Carbon Cities Master Plan, NLCCM requires 15 local governments to achieve carbon neutrality by 2050. And the last one is CASA has previously established recommendation called the 3M approach, which stands for measurement, management and mitigation, with the goal of reducing carbon dioxide emissions. We have two main objectives for this project. Firstly, to measure the emission of carbon dioxide at an urban signalized intersection. Second one is to determine the correlation between carbon dioxide emission and degree of saturation, delay and Q distance. For scope of study, this research will utilize secondary data collected from night crossing in Bandar Maharanima, and here's the list of the location. Next, we move to significance of study. Specifically, the purpose of this research is to quantify the amount of revenue created by urban signalized in Bandar Maharanima. Aside from that, according to the information received, the air pollution index is within the range established by the National Air Pollution Agency. Last and the last part for Chapter 1 is thesis outline. It has 3 chapters. Chapter 1 summarizes the introduction, issue description and data collection and analysis. A literature review is included as well of our information on Citra intersection 8.0, carbon dioxide emission at urban signalized intersection and other relevant carbon emission information. It also contains a study area and a data gathering mechanism.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin bin Zahanuddin and today I will present about the literature review. First and foremost, taken from Weight and Pen 2017, carbon dioxide CO2 emission from urban transportation are causing increasing concern around the world. Besides, according to Arzang, due to vehicle acceleration and deceleration, intersections are often regarded as high emission sites on the road network. The more time spent in traffic, the more gasoline is burned, hence resulting in increased vehicle emissions such as carbon dioxide and carbon monoxide. Next, the emission of greenhouse gas are commonly related to industrial activities and transportation sectors. Meanwhile, Nocera state that the increases of carbon emission are mostly due to the road sector, with 93% approximately of the total transport greenhouse gases emission which emit by the motor vehicles, including travel, driver, facility, fuel and overall environmental characteristics. Based on Weight and Pen, recent research in 2008 by Center for International Climate and Environment Research Oslo, carbon dioxide emission had increased by 13% in the past years, where the transportation sector was as high as 35%. In 2000, emission from transport account for 13.5% of the global total and rose to 23% in 2009. In 2002 to 2007, China recorded an increasing of transport emission at the rate of more than 10% each year. Whilst several studies shows no smooth operation and stop and go activities are main causes of excessive emission at urban junction taken by Huang 2021. Intersections have more acceleration time due to stop and go traffic. This system may cut traffic emissions at junction by minimizing unnecessary brakes and acceleration. Here are factor indicator investigated by Prisbilla for the effects of intensive driving on vehicle trajectory. First is supply factors. Urbanization, city spatial layout, traffic planning and operational management are among the variables that contribute to traffic management. Larger roads may reduce traffic-related pollution as a result. Smart road design that increases junction connectivity has been proven to dramatically reduce congestion, taken from Glasson 2007. Next is demand factors. As traffic demand rises, so does car ownership. According to the World Bank, China had 86 per thousand people owning a vehicle in 2014. Since transportation costs influence consumer demand, most nations have used economic measures to reduce traffic. Lastly is environmental factors. Population density and growth rates are both a demographic and economic variable. Environmental variable represent the external environment in terms of demography and economic development. Population growth increases traffic turnover, demand and pressure. Studies show that population expansion increases carbon input and decreases carbon sinks. One of the examples of method used to analyze the carbon emission is Nocera introduced the 20-20-20 program, or in detail decrease the carbon emission 20% by 2020. Then it has been integrated with the 2030 initiative, which is reduce the greenhouse gas production by 40% in 2030. Here are some studies that use another software to analyze the carbon emission. Citra intersection is a software that supports various movement classes such as bus, vehicle, motorcycle and others with a variant vehicle characteristics. Citra intersection uses 4 mode elemental to precise the acceleration, deceleration, idle and cruising features to evaluate the data such as cost, energy and air pollution consequent with the intersection design. This software also can estimate of acceleration and deceleration times and distance for light and heavy vehicle, as well as an acceleration time profile polynomial model. It also offers a wide range and intersection and network performance metrics, as well as a variety of alternate level of service (LOS) technique and target settings for determining appropriate intersection and network architecture. That's all from me. Thank you.
Our studies begins with literature review, followed by data collection, data analysis, and lastly conclusion and recommendation. For data collection, the study will be using secondary data, which is the data that was studied by previous researchers, and the data will be focused on peak hour. Here is the example of the secondary data that will be used. For the data analysis in this study, Citra intersection T.0 will be used to find the amount of carbon dioxide emission. From the software, there are some steps of calculation to find the emission of carbon dioxide. Finally, from all the 11 steps of calculation made before, the values of instantaneous carbon dioxide emission rate are estimated directly from the instantaneous fuel consumption rate. All of the data, including carbon emission, degree of saturation, delay, and Q distance, are tabulated to generate a clustered bar. Next, all of the data will be used to run the analysis to determine the correlation between carbon emission and degree of saturation, delay, and Q distance. So here is our layout of selected intersection from Jalan Bakri. From the tabulated data, it shows that 006 intersection, which is Jalan Pesta 2, recorded the highest value of amount of the CO2 emission, while intersection 005, which is Jalan Haji Jaib, recorded the least amount of the CO2 emission. As the amount of CO2 emissions recorded, the value is compared to the degree of saturation, delay, and Q distance. All of the data are tabulated and used to generate a cluster bar to compare all of the data obtained from all of the intersections. Lastly, the correlation coefficient is determined to prove whether there is a presence of relationship between the amount of CO2 and degree of saturation, delay, and Q distance.
In conclusion, our group has succeeded to fulfill all the objectives stated in Chapter 1. Our group are able to measure the emission of carbon dioxide at the signalized urban intersection which is 9 intersections in the Jalan Bakri Muar. Our group also able to determine the value of correlation coefficient between carbon dioxide and degree of saturation, delay and Q distance. From the result, our group noticed that there are strong positive linear relationship between the carbon dioxide emission and degree of saturation, delay and Q distance, as the value is nearly to the value of the one because it produced such an accurate result. Last but not least, Sidra is the one of the best option for calculating the carbon emission. So, the higher value of degree of saturation, delay and Q distance, the higher value of the carbon emission. Our group hopes that in the future, there will be a study that able to identify the allowable carbon emission at the signalized intersection, so that carbon dioxide emission can be controlled and fulfill the policy of low carbon stated by the Ministry of Environment and Water. Future study needs to find the allowable carbon emission value that have a similar unit between the standard and the software used.